Hi, it's Miss Cantwell. I'm just here with your week 8 lesson video. Before we get started with the lesson video, I would like to make sure that we're all understanding that our grades are based off of the Google Classroom quizzes and not off of the Edgenuity quizzes. You're learning the material through Edgenuity and quizzing yourself through you're demonstrating mastery of the material through our Google Classroom quizzes. And those you can take as many times as you need to in order to get a grade you're happy with. And you can go back and still do the first quiz right now if you want to. So if you have questions about your grade and that doesn't answer it, then go ahead and send me an email or a comment on Google Classroom so that I can help you out. Okay, you had 2 units to work on, or 2 lessons this week. One of them was atomic spectra, and atomic spectra are super useful in identifying elements and substances. So let's talk about that. So at the or not at the beginning, one of the most popularly used models of an atom is the Bohr model, because it was developed by Niels Bohr. It talks about the orbits, and each orbit has a very specific energy level. So, in order to orbit outside, you had to have more energy than to come inside. Okay, so you couldn't be in between. The energy had to be quantized, which means you couldn't have half of an orbit. You're either in one ring or another. They can change their orbits by absorbing or emitting energy. So if we drop down to a lower energy level, we have to release a photon. Okay, and that is energy. It's a little particle like bundle of light. So when we let that go, that's when we are releasing that photon and we're dropping an energy level. If we're going to become excited, we're going to gain some energy to go from an inside to an outside. We are going to absorb energy, sorry. Okay. So absorbing the energy causes it to jump to the higher state. Okay. And then it releases that photon and falls back to the ground state. We always want to be at the ground state. So we have 2 different kinds of spectra. This is an absorption spectrum because you can see all of these colors of light are being reflected off of the atom except the wavelengths that are black here. Those wavelengths are being absorbed, and so this spectrum specifically will tell us which wavelengths are being absorbed. Okay. Um, this is an emission spectrum here, the bottom one. So you can see that everything is being absorbed except these very thin colored lines. And those are the ones that are being emitted by the atom. So every element is going to have specific wavelengths of light it absorbs or emits. And that's how we can use this to identify elements present in certain substances. So you can also see kind of which elements are present in the light that comes through. So we see this is an absorption line spectrum. So we've got 2 wavelengths specifically that are being absorbed here. Okay. Now, the next thing we're going to talk about is medical applications of nuclear and wave phenomena. So I have been through almost all of these procedures, but they do all use either nuclear principles or wave principles. An MRI, magnetic resonance imaging, it's a very, very powerful magnetic field generated inside this tube, and it makes the nuclei in the body in specific areas where it's targeted get excited. And when they do that, they release radio waves of certain frequencies as they drop down. So in that case, It's similar to the absorption emission when it emits the photon. This time they are releasing a radio wave, which is on the lower end of the EM spectrum. And it's a specific frequency. So then they catch the waves and then they use that to make an image. This is one of the ones that I haven't had. I think the key here is that it's a powerful magnetic field. We're basically bringing these atoms to an excited state, and then they are releasing those waves as they go back to ground. I haven't had that one. CT scan, I have had. It's computed tomography, excuse me. What this does is it takes x-rays from lots of different angles, and then a computer is able to process it so that we can see cross-sectional areas of the body. So this would be a cross-section here, okay? This one, they might use contrast, they might not, it just depends. But it is x-rays. So again, those are a little bit higher up on the, or actually they're towards the high end, I'm sorry, of the EM spectrum. So this is why you have to be careful, like this as part of radiography, you have to be careful about how much of that you are getting, but the doctors are very good at monitoring that. Ultrasound is the only one that, no, ultrasound, I'm sorry. Ultrasound sounds like a sound wave, but it's actually, well, it is a sound wave. The only one that's not the EM spectrum. So the frequency of the ultrasound is super high. We can't hear it, but we can use the amount of time that it takes for the wave to go through the medium and come back, as well as how much the wave is going to refract when it goes through the different media to make a map of what's going on inside. So this obviously is a, a fetus, okay? But I've had ultrasounds on my heart. You can have ultrasounds on a vein. You can have, and you can also, they can do a lithotripsy too, which is using super ultrasound waves to break up kidney stones. So those are applications there. PET scan, okay? PET position emission tomography. This is when a radioactive tracer is injected into the patient. They release positrons, which produces gamma rays. So then the rays are detected, and we can use those to make a map. So I've had one of these. And what I had actually is a PET CT. So it combines both of those methods. The PET, where you have a radioactive tracer, mine was a form of glucose. Where they were trying to determine which areas of my body were metabolizing or had the most active metabolism, because that would be, well, your brain is going to use a lot of glucose, and your digestive system, but anywhere else it would be abnormal to see a high metabolism rate. So that's how they checked for tumors. But then also it utilizes the x-rays. Okay, so we're getting kind of a double whammy there, where you have x-rays taken from different angles, and then the gamma rays, which can be detected, and they work together to make sure that everything is in the right place and create a more detailed map. There's also the CT scan uses x-rays. So there's a difference between like a radioscope, which would be like your typical x-ray, and something called fluoroscopy, which is a little bit different. So fluoroscopy is like a live image. Like the doctor can look at the image, place a catheter, place a needle, and see exactly where he's going in real time. Whereas in an x-ray, it would be kind of like a before and after kind of thing. Okay, LASIK. Laser assisted in situ keratomiliosis. Okay. What they do is, this is the procedure that people use to correct their vision without the use of contact lenses or glasses. They basically use a laser on the eye to create a flap in the cornea. And then there's another laser that they use to reshape the interior of the cornea and improve the patient's vision. So, um, lasers are beams of excited electrons, and then the reason that they have to reshape that cornea is because of the way that light refracts through it, through the lens as it goes in. Um, they're trying to adjust the angle so that your vision will be better. Last on this list, we have radiopharmaceuticals. They are medicines, pharmaceutical drugs that contain isotopes. You can use them for imaging purposes, basically, how fast is this breaking down and where is this breaking down. They can also use it to treat diseases. A lot of the, several of the chemotherapy drugs are radioactive, and they will attack those cells that are rapidly dividing. That is it for this material. If you have any questions at all, feel free to contact me. Email or Google Classroom is fine. I hope that you're staying well. Please, I know you want to, but don't relax on your social distancing stuff. Make sure you stay with your family, with maybe a few other people, but we really need to still be careful. And then also wash your hands, don't touch your face, all that stuff. I really miss you guys, and I can't wait to see you again when we go back to school. So just be careful and stay in touch, okay? Good luck on your quiz. Again, ask if you have any questions. All right, bye.